as you already saw, About Logic really asks the questions where people can find what's your favorite theorem prover. So let me come up with something less problematic, namely law, where things are easy and there are no disagreements. So great that you tuned in to our next episode of About Logic. And we have a great guest today here, namely Alexander Steen from the University of Greifswald, where he's a professor for computer science. And he's a professor for the best kind of computer science, namely theoretical computer science,
Exactly.
dealing like with symbolic artificial intelligence. Yeah, thank you very much that you joined us.
It's a pleasure to be here. Thanks for the invitation.
So would you like to give us like a very brief 2-minute quick introduction? What is your research about? What are you working on?
Well, if you don't keep the time, I promise to not...
Plus minus 2 minutes. So.
Sure. So I'm in the broader area of automated reasoning, more focused in automated reasoning. So this is a field where we try to develop methods and also implement them on the computer that automate logical reasoning. So the main question is, given some set of assumption expressed in some kind of logic, like in math, right? I want to have a computer system that does the proof for me that some formula actually follows from these assumptions. I guess everybody that's studied math or studied math or research math knows that most proofs are probably done by hand. So I have to think about it, how to prove it, get a proof idea, write it all down, hope it's correct. And the hope, at least, is that these kind of systems will find the proof automatically without any guidance from the user. And this is so my main focus is the development of these kinds of systems. We know that, of course, in general they cannot exist because we have some limits established for automation, some undecidability results. But nevertheless, they work quite well in practice. So this is the main topic, and the second half of the picture, more or less, is the application of these kind of formalisms and the automated reasoning in application domains. So I've been very interested now, since I was in Luxembourg, in automated normative reasoning, which means automated reasoning, but not necessarily with respect to mathematical notions, but with kind of norms. And I want to show that maybe some obligations on this side follow, or some permissions or whatever, so some kind of normative statements. And this is a very interesting topic because it's much more complex, I think, at least. And so this is roughly my area.
Just a question to the first part. I mean, I'm working with interactive proof systems. So there is so there the user drives the proof, but it's convenient if sort of trivial goals are automatically disproven. What do you think about this?
Yes. Yeah, I think the truth is, as always, somewhere in the middle. So I think you want to have both. Because we know from experience that the automated systems, I mean, most of the time, the thing that you actually want to prove is very complex, right? So otherwise you wouldn't bother using that system anyway. And if it's complex, there's a good chance that the automated systems will actually never find the proof, because we know it's undecidable, and even if we know it's true, the proof may be really hard to find. And the advantage, of course, with interactive proof systems is that you as a human user, have a proof idea, and you just have to convince the machine that your proof is actually correct. Just as you say, I mean, there are often steps in larger proofs that might seem trivial for us, or that are actually easier than we thought. So it's nice to just, during writing down the proof in a proof assistant, I can just check if the computer can already prove that by itself. If not, well, then I have to refine, and I have to do some, top-level proof structure, and then I can try again. But I think actually this kind of interaction between two kinds of systems, this is actually the most fruitful approach that we have, because we don't want to prove that A plus B is equals B plus A all the time. I mean, this is something that we want to automate away, right? And of course, hopefully also more.
Using
What,
this
sorry?
or using it in an algebraic derivation, right? Which can be quite annoying. Actually, it's not just about proving things; it's about constructing things. I mean, it's about. So I find that interactive proof systems help me with sort of discovering the theorem. I mean, formulating it, the definitions, and interactively working with them.
Yeah.
So it's not just proving something, which a system, an automatic system. I mean, not a deductive system could not do, because it's really in a way inductive in the general sense, right? I mean, instead I discover the notions I want to prove, right?
Yeah, sure. Yeah, that's true. I mean, usually in this kind of interactive tools, you have a whole spectrum of tools that you want to apply, right? So there's some tools for simplifying goals, sometimes for proving small goals. That would be the automated theorem provers. Probably also some tools for checking for counterexamples, so finding counter models. And also, I mean, I fully agree with you when thinking about a theory, when constructing something. So in the process of actually thinking about the project, about the thing that you want to talk about, often using tools that give you counterexamples are probably the most helpful ones to clarify your own understanding of the matter that you're actually working with. So you can extract some kind of corner cases or some kind of hidden assumptions that you haven't, written down because you haven't thought about them yet. And I think you need both, right? You need some tools that push you to, reflect about your current assumptions, and other tools that help you in the broader sense for proving stuff. But so also automated tools that do not prove but actually find counterexamples. I mean, they are both equally important.
So maybe Dennis want to say something?
Thorsten, maybe continue with your line, because I would go for the other half of your.
No, I was going for okay. Maybe that's the question. What is your I mean, are you using? I mean, I think you're involved in a paper which is using Isabelle. Is this your favorite proof system, or have you looked at other ones, or do you know something like Lean or Rock, as it's called now? Or
right. So this is a mean question, right? Because regardless of what I say, I will infuriate somebody. Let's just say Isabelle is the system that I've worked most with, and also that I've been introduced first with when I was a student. And I really like the proof language of Isabelle. It gives you both, the tactic stuff, that you apply some kind of rules, but also the structured proof format, ISA it's called. And this makes it also quite suitable for teaching about proofs, so the structure of proof, because you have a more or less a one-to-one correspondence between, a proof by contradiction always could look like this is a structured ISA template, or a proof by cases like this. And this is really what I like about Isabelle. I'm not saying that other assistants don't have that, but so this is the system I've worked a lot. Well, let's say a bit with. I've looked at Lean, at Hall Light, Hall 4, and Cork or Rock. Of course, with systems like Rock, I mean, it's probably harder to I mean, not master them, but get to a level where you can actually productively apply them, because the underlying theory is also a bit more complicated. Because sometimes if you want to just talk about some kind of functions and prove something, you don't want to think about dependent types and all the underlying complexities. I'm not saying that you probably have to understand all this, but it feels a bit overwhelming maybe at first. But I mean, I've also worked with Cork back then, and actually liked the interface quite a lot. So I think I don't have a preferred system. I think probably they are useful for different, or maybe slightly different applications.
I mean, I think I have used this a while ago that I used Isabelle, but if you want to focus on representing structures in mathematics. I mean, Isabelle is good for deductive reasoning, as you say. But if you're interested in formalizing structural mathematics, like reasoning in whatever categories and so on, I have some issues with Isabelle, but let's not get too deep into this in the moment. Yeah.
Of course, one of the most important points is that my prover, the Leo 3 prover, is integrated in the Sledgehammer 2 of Isabelle. So of course I have to say if you want to use Leo, you can use Isabelle and invoke it, right?
So what exactly is Leo then?
Leo is an automated theorem prover. This is integrated like in the portfolio of solving proof goals in Isabelle. It's an automated theorem prover for high order logic. Which is also the language of Isabelle. And I think it was integrated somewhere in 2020 or before. So, I mean, it's not like a very mature system like the ones that are the standard tools like CBC and Z3 and eProver, iProver, whatever they're called, right? Because it's more or less now a one-man show developing Leo 3, but for some applications, it actually gives some good results, and I think quite nice proofs. So, so I'm all in favor, of course, of using my tool. But yeah, well,
sure. Otherwise, why would you have
a
written it?
Very minor point. I mean, nowadays it's about groups of theory automated provers, anyways, right?
Sure.
Because in the very first milliseconds, you prove so much more than in the last of your window. So just try our 10th. To get the best
There's
results.
no reason for not doing it, right? Because we have the computational power, we have multiple cores. It would be naive not to try different approaches all at once. I mean, yeah, sure.
Okay. Great. So as you already saw, About Logic really asks the questions where people can find what's your favorite theorem prover. So let me come up with something less problematic, namely law, where things are easy and there are no disagreements.
Okay.
So
let's see.
I mean, how can I imagine that? That did you take like the whole legal book and formalize it and then start from there? And how is it about the different kinds of reasoning? And when you sit in court, you normally don't get these lovely clear deductions. You get abduction. It's all messy. So how can you get these two things together?
I don't know. Probably you can't. That's the short and simple answer. But no. I mean, I still feel like I'm scratching at the surface, and now have been looking into normative reasoning for quite some time. I started doing this, I think, in 2018 or 19 or so. So it's quite some years ago. But so we have to be careful when we talk about normative reasoning, and of course applications in a legal context, because there are of course some things that are different, right? I mean, of course, probably in all legal processes there are some kind of normative things involved, but the other way around, I mean, it's not necessarily the case, right? So I started looking at non-classical logics that have been designed for dealing with normative information, and this is what I would say. So the automation of them, not like the philosophy of them or creating new logics, but really automating them. So this also means that I'm really no expert in how to choose which logic is the most appropriate logic for representing some kind of stuff. Because this is, I mean, for real use cases, this is really hard, a really hard question. But then again, after just looking at the logical core, so at the actually automation process of normative reasoning, I wanted to do something with it that feels a bit, helpful. So I actually looked at German legal processes and what we could do with such kind of technology in that context. And I've been in contact and close collaboration actually with a lawyer, or no, he's not a lawyer, or I'm not saying that, right? He's a notary. This is something completely different. At least he told me that. And for quite some years, I've been explaining logic to him, and he has been explaining legal topics to me. And I think it actually took more than a couple of months until we actually agreed some common consensus for the usage of notions and phrases and some kind of, terminology that we actually are talking about the same thing, which is a very non-trivial thing. And then, of course, when you apply stuff to topics from the real world, it becomes more complicated. So it was the first point where I learned what actually is the the difficulties in really, the legal process. And I agree that a lot of things there are not a deductive process. But the goal is probably not to automate, like to have a judge automaton or something, where we automate, a court case. But probably you want to have some kind of assistance systems that, can help a human for decision making. So we looked at certain steps in the legal process where we think that actually some kind of logic-based AI reasoning tools can be useful. This could be for, discovery of relevant norms. That can be for checking whether some kind of argumentation is, consistent within itself with respect to some kind of, framework. Because usually the problem is not that you want to verify that some kind of court ruling is correct, which you cannot do anyway, because the judges, they are independent, and one judge would probably come for a very different outcome than another judge would, but both are right, because they're judges and they do whatever they do, and then they reach a conclusion or some kind of verdict, and the important thing is
that the judge will take the intent of the law into account. I mean, what is intended, and not so much what is sort of deductive conclusion,
exactly.
right?
Exactly. So we have the problem. So what does norms actually mean? You have open texture. So when it says vehicle, is vehicle really meant when we think about vehicles? Is a legal term? What is subsumed by that? What is not? It's also that you can, at some points, you can choose. You can choose whether you apply this norm or that norm, or whether you think that there's some kind of case where it makes more sense to apply another norm because you judge the situation to be different.
Yeah, so you judge that the intent of the law, the lawmakers, was exactly this. Yeah,
exactly. And so I think the thing that we can do, probably, maybe at some point, is that we can check whether the argumentation of a judge is somehow non-conflicting with some kind of legal constraints. But of course, we could not really, construct the legal outcome, because legal outcome, I mean, it's so intricately dependent on which path you take through this whole network. But maybe we can show that a path was taken that is actually allowed. And I mean, we have this phrase called Rechtsbeugung. I don't actually know what the English term would be. I mean, it's, you're not applying law as you should do. I have no idea what's it called.
I don't know.
Bending should be.
Yeah, bending the law, maybe.
Bending the
I
law.
don't know. I don't know. And of course, this is not allowed, right? Because judges, I mean, they're independent, but that they have to adhere to the law. And maybe you could have some kind of, I wouldn't say it's verification, but some kind of sanity check if the argument is within the scope of the law, within the intent of the law. And this is probably the interesting thing that I am step by step looking at.
We have got some bad, we have some bad history, right?
Yes.
Thing of Reisler immediately. No?
Mm-hmm. Exactly. But of course, from that, so other applications could be, intelligent way of looking for the most probable applicable norms, because there are a lot of, norms out there. Which ones do you take? Maybe it's already a simplification of a process if you can use a tool to find you, in a semantical sense, the right norms that might be applicable in your case. So you can, probably as a legal expert, you already have them in your mind anyway, but maybe you forgot some special rules or so. I mean, some kind of a systems, right?
I mean, sorry, the term is perversion of justice.
Perversion of justice. Okay. Well, that
Okay.
sounds suitable. Yeah.
Yeah, but I mean, obviously, in this area, you are in competition with, I mean, machine learning and large language models, which
Yeah.
I mean, I'm not working in this area, but to me, there seem to be a better match to legal reasoning than a sort of a formal system. I mean, to say this, I mean, I'm interested in formalization of mathematics and mathematics. I'm by the way, I'm slightly always offended if somebody says non-classical reasoning. I mean, I'm an intuitionist, which is non-classical, but it's very different from these epistemic logics you take into account. Yeah. So I mean, maybe the term is non-ideal or non-mathematical logic, right?
Yeah, I think it depends on who you ask. I mean, also
ask
I
me.
heard expressive logics. I heard domain-specific logics. I think it's always the perspective from where you're coming from.
To me, I mean, to me, the point here is what I say epistemic. It's about the actual human reasoning, whereas in mathematics, whether it's Platonic or not, we want to in a way have a good, I say ideal, but that sounds very Platonic. So the best possible approximation on what we mean by mathematical reasoning, and that's but this is very different to this normative, deontic, and so on reasoning. Quite a different area. And And so my thesis is that in mathematics, for mathematical logic, let's say, the logic in mathematics, well, mathematics isn't just mathematics, it's to computer science, it's to physics, whatever, yeah. There I want to use a formal system. But I have my doubts whether the formalization of epistemic logics, I mean, like the logic of discovery was also attempted, right? Logic, inductive logics, and so on. That this is something I'm not convinced that this is sort of very helpful to formalize this.
I guess it always depends on what kind of goal you have in mind. I mean, usually, I mean, this kind of, I call them non-classical logics, but I see that, I mean, this term can be disputed. I mean, they arise and die somehow, like every year. There are a lot of logics that have been created and probably not been looked at again in the context of AI applications, because in AI applications you usually have some kind of very specific application scenario in mind, and you want to model it, and then you need some kind of, I don't know, you have some agents, you need some kind of logic that can deal with agent, maybe the knowledge, maybe communication. So you create a new logic that has all these kind of ingredients because you want to model that kind of scenario. And of course, these kind of logics, they come and go, and probably I don't know how many logics are being created anew every year at conferences like ICHI or ICHI and whatever. But these kind of logics, of course, they have a use case in mind. And I think it's actually a nice idea to have some kind of abstract description of what you want to achieve, but that doesn't necessarily mean that this logic is already, the holy grail, that it can do this kind of stuff. But it gives you, again, some approximation on what kind of real-world challenges you actually want to look at. Because real-world, I mean, this is sounds a bit floppy, but of course, real-world problems are often much more complex than mathematical issues, when you also need to incorporate some kind of, human factors, some kind of physical factors of the real world, whatever, and they can kind of try to model that, well, to some extent, right? So they are tools, and I think automating them, these kind of logics, can help if you want to, build an AI system where it's not all about machine learning and all about, data-driven statistical inference, but you want maybe to have some kind of assurance some kind of checking actions, some kind of hybrid approach where you can, play the strengths and weaknesses of both worlds somehow intermingled in one system, right?
But that's what you're saying here seems to be what I would call the classic AI approach, right? So there is this new, sort of machine learning idea, which I was interested in AI when I was a student, but then I drifted off into logic and theoretical computer science. So isn't the challenge that these that statistical methods are actually working much better in these fuzzy areas? And do we actually need this old AI, which you defend, right?
Well, it really depends on what you want to do. I see the point that, and this is completely right, that for a lot of applications, the kind of ML systems, they seem to deal quite well with some kind of problems that we couldn't dream of, attacking with some kind of symbolic approaches. But then again, for some kind of simple applications, they really don't work well. Maybe you want to have a system, some kind of, so what they call it, mission critical. This can mean anything, like healthcare, legal, whatever, context where you want really to be sure what your AI system is doing.
But can you be really sure? Sorry, because you have to believe in this sort of formal logic, which is maybe not much help. Especially if we now look in the legal business, if you look at the practitioner like your colleague, if you say, oh yeah, this logic captures what you mean, and does he really, or does he or she, do they really understand this? Or do you really understand this? How this logic matches with the sort of more intuitive, informal reasoning? Yeah.
Right. Yeah, so what I think, probably you want to have both, because in some kind of, in our kernel, in our core, you want to make sure that some kind of very low-level steps, of low-level reasoning steps are sound. That the system is really just doing what it's supposed to do. If that's
but
complex,
what's supposed to do is the hard thing, right? Do you not create the illusion of some kind of reliability, right? Because in the end, the logic itself is maybe not completely transparent.
Sure. Well, then we're not doing any worse than the ML systems, right?
No, you are in a way, because the ML system is more emulating the sort of fuzzy reasoning humans do. And if you think about especially supporting legal experts, obviously looking in a large database of cases and find matching ones and learning what matching means, that seems to be very, very much in the domain of an LLM or of a machine learning system.
But yeah, for things that you can learn, yeah, sure. But what's the point of learning some kind of norms? Where we already know what the norms are, when we can perfectly describe them, we already have them written down in a symbolic form, okay, not in logical form. But you really don't want to.
It's about clearly the application. Matches this case, right? This is something which the legal student has to learn, right?
Right.
And they learn it actually in a very, I don't know. I'm not a legal student. I know somebody who is, but maybe I should discuss it with them. But it's much based on looking at cases, looking at learning from examples, right? And that seems to be. I'm just saying.
Yeah.
I'm talking about the devil here, because I'm not too. But
but then again, there is, at least in the German legal concept, or in the so if you study this in Germany, there is what they call Rechtslogik. So legal logic, or part of, I think, what they call rechtsdogmatic, the things, how they're supposed to work. I mean, everybody knows that in practice they probably don't work like that, but this is the ideal. And the hope, of course, I mean, at least that's what I think, is that at the heart of this Rechtslogik, of this legal logic, at least that's what they describe in their legal books, right? These big legal books. They describe that there is some assumption progress going on where use some kind of inference from this and that. And of course, this is not as formal as like a logician would like that, but still some kind of ideal where we all know that this is not working in practice. But there is at least the kind of, I think it would be, I mean, they claim to be very objective with respect to how their deduction process or how the inference process works. In practice, I would doubt that this is actually really objective and so objective that it can be done in logic. But I think that some aspects of this kind of behavior, of this kind of steps that are going on there, can actually be described in logic. And I find it interesting to actually have a model that matches maybe not all, but most, or maybe at least some relevant notions of this kind of legal process, and to put them to good use. And I think when we have automation for this kind of stuff, we could at least try to somehow combine the strength of this kind of symbolic approach and the kind of machine learning approach, to do some fuzzy reasoning with ML, and maybe to have some kind of reasoning involved and see at least if they're conflicting or not, to at least have some kind of indication whether you should probably look closer, or if there is, I don't know, if there's no conflict going on there, and we will maybe be able to trust the output of the system or so. I mean, I'm not saying that this is, Holy Grail, right? But
I wonder whether this is also related to this. I mean, I think German law is mainly Roman law. It's of deductive, right? Whereas I live in the UK, where this is Germanic, more case-based, right?
Yeah, this case.
And I wonder whether this has an impact on the sort of Rechtslogik, so logic of law here. Yeah.
Definitely. So I've seen a lot of papers about AI in law is a relatively big community, and they have very active conferences there. And I've also been part of these conferences for some times. And they have some papers on, case law or non-case law systems. But I have to be honest, I mean, I'm not in the details, and I couldn't really understand that back then. But so definitely there's, a clean cut, at least it feels to me like a clean cut for methods that are more applicable to the one or to the other. So,
I mean, to put your skepticism, Thorsten, into a question, it's oversimplified, but if somebody tells you here, this legal aspect is part of your life, let's say a judgment whether you were guilty or not, and this part is checked either by a real judge, by a LLM, or by a theorem prover, what would you two choose? I mean, it's not how it works, but
the judge definitely.
In that case,
but the
judge,
but there is a
theorem prover, and
but
the
there is
LLM
this problem that the judge
option,
is overworked, and we have an issue with especially asylum cases, which creates lots of excitement, right? There's a big backlog because there's basically not enough judges. So yes, we need a judge, but we need to make the judge maybe more efficient, right? And the question isn't so much a judge or some computer, but how can we support the judge and the legal professionals most effectively? Yeah,
exactly.
And I have to admit that my feeling or my preliminary conclusion, let's say, is that LLMs would be much better suited to this than formal epistemic logics.
I would be worried about hallucinations.
Sure,
and
but I'm worried
things like that, which I would be less worried in case of theorem provers.
No. I'm worried about the theorem prover because it gives you the illusion of reliability, where the mismatch is then whether the logic actually corresponds to what you actually want with what is your goal, right?
Exactly.
And that's much more dangerous, because you can always say, oh, this LML is just hallucinating. But if the deductive system promises, oh, this is a conclusion, you are now going to be executed, because according to this logic, I mean, you should die. So come on.
Yeah, I mean, there are deontic logics where I can prove that you're allowed to kill somebody just because of some triviality.
Yeah.
I completely agree, right? Because this is something that probably also students or experts in fields like computer science or mathematics are not often don't often really have a feeling for that there are many different logics, and they have their subjectivity but hidden in the logic. The mechanism is very mathematical, and very it looks like objective definitions, how we infer stuff, right? But of course, it's built in the axiomatization or rules or whatever of the logic. But yeah, I mean, of course, then again, I would say, well, I know that. Why shouldn't the company or the public government who orders this kind of system, trust in a logic? Because logic was probably designed for especially that purpose. So it's just part of the requirement elicitation process, and we should know what it can do and what cannot do. I mean, this applies for machine learning and logic-based stuff equally, I would say. But yeah, I get the feeling that probably for a layman, I think it's now clear, not now that everybody probably has played with Gemini and ChatGPT and whatever they're called, that they know that there can be spooky things happening there. But once you hear, oh, this is a system that is proved correct, whatever that means, then probably I mean the level of trust, at least the subjective level of trust, is much higher. And of course, this is a danger, but that for me it doesn't necessarily imply that these kind of tools or this kind of methods shouldn't be a suitable addition to the suite of tools we have.
Sure.
But of course, it's true. I mean, in deontic logic research or normative logic research, I mean, as far as I know, they still haven't settled on what kind of logic is, the right logic for doing deontic detachments. So how should we do legal stuff if we haven't really understood deontic inferences yet, right? So this is an ongoing research, right?
There's the question posed by Lakatosh. Now, for the mathematical case, what would happen if number theorists prove that Goldbach conjecture holds, and we have a deduction that Peano arithmetic proof that Goldbach conjecture doesn't hold? And back then, Lakatosh was optimistic that the number theorists would say, well, let's just get rid of Peano arithmetic. So maybe let's hope that legal.
So you mean that Peano arithmetic is inconsistent, or what? I mean, this is what Wowodzki suggested actually at some point.
Yeah, I mean, you don't need full inconsistency, right? You just need one disagreement where Peano arithmetic is
disagreeing with
different
what?
in scope than
disagreeing with what?
With number theoretic practice.
No, but I don't
number
understand.
Theorists see some.
You mean
they see a proof of written in ordinary language, and then they agree, oh, this is a lovely proof of Goldbach's conjecture. And
but shouldn't they be able to say what they used in this proof? I mean,
or do they?
No, I
just
know.
write in the preamble? Oh, I use ZFC and maybe Grothendieck universes, but I'm not sure about that. Who cares?
Okay, but in this case, I mean, then you shouldn't leave the mathematicians alone with this. You should call your emergency logician.
We should never do that, yeah.
So like emergency logician number has to be called, and the emergency logician has to check this, So I mean,
they would look from both sides apparently, right? They would see, is this formalization really adequate, or is this natural language proof really adequate? And similar, I guess, in legal context, right? It's just it would alert you if there is disagreement.
But I
And I
think
mean, I made it binary, take this or that.
no,
In
but
reality,
the
you would
comparison
investigate both.
isn't really working. I mean, in mathematics we can boil down things to some sort of ideal reasoning. In law we can't. This is really a different area. So the analogy it isn't working.
Yeah, but still, I mean, it's true. Still, in the sense that just like we said, that once you settled on some kind of logic, I mean, of course, you have some kind of inferences within that kind of logic, but you will never know. It's really hard to know whether the logic you choose is actually the right one. And this
Right.
is, I think, this is an aspect I think that many people actually don't think
Yes.
about that much.
So even in mathematics, the idea of the right logic is
Sure.
very problematic. I mean, that
Sure.
is in common with legal. But I think the fact that mathematics is striving for sort of some idealized reasoning, to what degree this can be achieved isn't clear. Yeah, and even by striving for this idealized reasoning, it's not clear exactly what principles, what axioms we are accepting. But I think law is really different. It's really based on human interaction, evolution of culture, evolution of ideas, and reflecting this. So it really is fundamentally different. Yeah. So
But still, I mean, of course, probably you want to look at one legal system, and within that one legal system, there is some kind of method on how. At least I know that for the German system, in principle, where you have some kind of objective measure, right? In principle, how to do some subsumption and come to legal conclusions. But I mean, I agree. Not the legal process is idealized, but I think some portions of that legal process can be idealized. Yeah.
Okay.
If somebody checks whether I submitted something in time, I hope this is not a matter of discussion, but about arithmetic, and so they are arithmetic can solve it.
And you
But
think
maybe there are
that legal people can do arithmetics, right?
Do we need real numbers? Is this not Zeno? I can submit always a bit later.
Right.
I'm astonished that this even works after the deadline for quite some conferences, but maybe I shouldn't say this aloud. A lovely topic, I mean, quite complex one.
Yeah, it is.
We are close to the time limit, but
really?
I mean,
Okay.
that this aspect of checking the formalization is one where I just wanted to say, maybe that's the reason why we need philosophers. They should check whether this part worked out. So a lot of working with concepts. It's an interdisciplinary endeavor, right? And computer science, legal.
But then we need philosophers
philosophy.
that are also trained in legal studies and also trained
Exactly.
in
Yes.
chemistry and in biology. And because, I mean, essentially, of course, this knowledge engineering part, I mean, this is the really hard part, right? Because, I mean, you can be, usually you're an expert in logic or in chemistry, but probably not in both. But in practice, if you want to use, some kind of symbolic representation for, I don't know, some reactions or so in biology or biochemistry, I mean, you need your domain knowledge, right? And this really calls for interdisciplinary approaches, interdisciplinary studies, projects, because you need experience and domain knowledge from all of these areas, right? Yeah. Including
the
philosophy.
last sociological question, maybe. So you joked around the lawyer not liking arithmetics, and I mean there's some truth to that. A lot of friends of mine who studied law said, I picked law because I really don't like math, and I hoped to get rid of all math. And then they were a little annoyed how formalized like some parts of their practice were, like getting a particular style to write this or that document and really needing to fit schemas, so to speak. So there's a formal element they hope to get rid of, but then yet it was back there. Long story short, have you a rough feeling how open practitioners are to your kinds of approaches? Is this something they find interesting? Is this something they hate? Something they are willing to open up or want a black box without looking in?
I have the feeling that they're not too happy about it. So, I mean, I get the point that once you have the feeling that this research would go into the direction that, that this would, somehow make your jobs somehow, easier, I could understand, but make your job meaningless because it can be optimized. And of course, I would say, yeah, sure, I can understand why they're not a big fan of it. But the more I study this topic, the more I think we are so far away from, doing some kind of automation or even semi-automated assessments that this is not going to happen. But the problem, of course, is that in practice, I mean, lawyers need systems that work, and we as scientists usually write down research software that demonstrates something, but maybe probably doesn't work in practice that well. And there's, of course, a big gap in research software development where we need some kind of, gluing part between these both worlds to make it attractive for the application side to actually test some kind of systems, because they don't have to go not just one extra mile, but, a lot of extra miles. But usually in research, I mean, you don't have that many resources to actually, care a lot about software in such a way that they can actually use it. Because they would, include industrial style, deployment of software with quality assurance and documentation and that stuff. And this is, I mean, we don't have the money for that, right? So, of course, there's a lot of factors, including this one, that makes it hard in practice to test out these systems. And of course, in real applications, of course, there's also a data protection, and this stuff. But I think in general, whatever makes the working life of a lawyer easier, I think he or she is happy to use. I mean, I would be surprised if it wasn't so. And I know of one system that was actually praised as one of the most helpful systems. I cannot recall where the context was or what the context was, but they had a plugin, I think, for Word or for some kind of Office product where they could highlight some kind of legal document in 3 colors, and one color was, I don't know, this was some kind of things that the mayor is allowed to do, and the other is what he's prohibited to do, and the other color was something else, I don't know. And they could now not just press Control F to look for the phrase, I don't know, fees, but they could look for the word fee just within the red coloring. And now they can look for, prohibitions about fees. And this was, I mean, from the research perspective, I mean, this is highlighting and a search in a color. This is trivial, right? But it makes their work much easier. And of course, there are a lot of these things that are from a scientific perspective, maybe not so interesting, but including like digitalization in general, that would make their life much more easier, which would be necessary to do the next step, to do the really research interesting stuff, with them. But yeah, okay.
So one last question, Torsten, or?
No, I think I'm fine. I should maybe come to an end.
Well, lovely. Then let me say thank you once again for coming here, donating your time at the very end.
Sure.
And I hope it was a little bit of fun for
it was a pleasure.
Us and
sure, of course.
Interesting.
For those who are listening. Yes, so subscribe. I guess you say that, not on YouTube. And we will have many more interesting logicians and people around logic here. So once again, thank you, Alex. And
pleasure.
See you soon. So this was another interview at About Logic. I hope you had fun. You can engage with other people in the commentaries below and subscribe and get the bell or something like that in order to get notification whenever the next interview comes up. So I hope to see you all around. And if you have questions we should ask, suggestions for people, do not hesitate to comment.